Basic electrical engineering. In our previous video, we are studied about the ceramic material, glass material, and the resins or plastic insulating materials. These plastic insulating materials, there are two types of plastics we are studied about. That is natural plastic and synthetic plastics, thermosetting plastics and thermoplastics. After that, we have studied the natural resins or natural plastics. The example of natural resins are amber, wood resin, shellac, like that materials. The properties of natural resins are not so good. It was not meet the expectations as an insulating material. Just it is used in manufacture of insulating oils and manufacture of insulation tapes, like that. The synthetic resins, that is synthetic plastics, are more applications than the natural resins. Synthetic resins are made by the chemical reaction of a chemical organic compound. Just it is resemble same as it is like natural resins, such as plasticity and heat resistance, but the chemical composition is completely different from that of natural resins. Due to its low cost, light in weight, low density, water resistance, and its molding and different colors, it is used in so many applications. 50% of the insulating materials are only from the synthetic resins. And after that, we are studied about the different type of synthetic plastics. Synthetic plastics means man-made plastic. Natural means it is available in nature itself. Wood resins, ambers, like that. To study about this synthetic plastics, first of all, this plastic is obtained by a chemical process called polymerization and are called synthetic plastics. After that, we are studied about the thermoplastics also. So what is this thermoplastics? These are formed by polymerization process in which molecule of a compound react together to form new compounds. In previous class we are studied about thermosetting resins. In this class we are going to study about this thermoplastic resins. So what is the difference between these two? The thermoplastic means they can melt and soften when heated and solidify when cooled. The heating cycle can be repeated without any change in the properties of material. But in this case of thermosetting, what happened? The molding temperature for this material is very high than that of thermoplastic materials. When heated first, they become soft, and on further heating, they undergo changes, and this change is set hard and it is complete permanent change. And after this stage, if we give heat further, then it will simply breakdown or by burning. So this process is called thermosetting. It is permanently set and does not soften on application of heat. But in this case of these thermoplastics, which retain their original properties, even we are heating. These are produced artificially from organic substance like oil and coal products. In these thermoplastic resins, fillers like mica, textile, wood, glass fibers are often added in order to get certain desired properties. These type of thermoplastics are widely used for floor tiles, walls, fluorescent lights, reflections, lenses, like that. So various types of thermoplastic resins are perspex, polythene or polythene, polyvinyl chloride, that is PVC. So most of the materials used in our worldwide is this type of thermoplastic resins only. It's not good for human life, but it is used widely. Because of that, due to its low cost and it's flexible to use. So what's the problem with this? It's never soluble in soil or liquid or in water. That's why our government also try to ban these polythene covers also. Right? You remember that? Okay. Right. Let's see. Here our topic is to study about this. So we will move to that. Here we are used different type of wires and cables in our house wiring and in our all the wirings related to electricity or the cables used in underground systems and transmission and distribution systems. Every time inside a conductor is there. You already know that. The outside layer is of different colors you are seeing. See, in our house itself, if we see near the fan, there are two wires is there. For example, one is a red wire and another is black wire, like that. So many colors it is appeared. What is that layer? It is made with the insulation material of PVC. Most of the wires all are used only this PVC material only. Okay, it is made by additional system of polymerization. This thermoplastic is made by addition system of polymerization. Here no cross links, chains of molecules, no cross links. That's why it is recyclable one more time, and it's very stronger. It's mechanically very stronger and low molecular weight, and also it is having very highly hygroscopic in nature and poor dielectric properties and less flexible. These are the properties. So let's see what are the applications for this. The applications are mostly for every wires and cables what we are used is this thermoplastic material only. So most of the wire used in our insulations is thermoplastic material. Right. The next is what? What are the example for this thermoplastic material? The example for this thermoplastic material is Teflon, PVC, polythene, like that. Let's see. What is this Teflon? It is a polymer of tetrafluoroethylene. This is a chemical composition. So what are the properties for this? The specific gravity of this Teflon is 2.1 to 2.4 gram per cubic centimeter. After that, the melting point is 327 degrees centigrade. Normal working temperature is 300 degrees centigrade. The dielectric constant is 2. Dielectric strength is 160 kV per mm. It's non-hygroscopic and non-inflammable also. These are the properties. After observing these properties, let's see what are the applications for this Teflon. The applications of this is capacitors. And this Teflon is used for making windings of the DC machines, that is in DC motors and DC generators. There are different lap winding, wave winding, like that type of windings is there. This Teflon is used as insulating material for these windings to prevent the short circuit from one winding to another winding. Non-sticky layer on electric irons. So this Teflon is also used at electric irons also, iron box. It's non-sticky layer. And hot plates, like that. Cable insulators for cable operating at high temperatures. After this Teflon, the next example is polythene. Polythene is a polymer of ethylene. Source of ethylene is mainly petroleum. So what are the types for this? The types is low density polythene and high density polythene. Let's see what is this low density polythene. The properties for this specific gravity is 0.91 to 0.92. The resistivity is 10 to the power of 16 to 10 to the power of 19 ohm meter. So it is having very high resistive material, and at the same time its melting point is just 110 degrees centigrade only. Dielectric constant is 2.28 to 2.32, like that. Dielectric strength is 20 to 160 kilovolts per mm. It's non-hygroscopic in nature. These are the properties related to this polythene low density type. Right. So these are the properties for low density polythene. Next, see the high density polythene. What are the properties for this? Specific gravity of this high density polythene is 0.95 to 0.97 G per cc, and its melting point is 130 degrees centigrade. Resistivity same as it is like 10 to the power of 15 to 16 ohm meter, high resistivity material. Dielectric constant is 2.25 to 2.32. Dielectric strength is 20 to 60 kV per mm, and it's non-hygroscopic in nature. So up to now just we are learned about the polythene low and high density types. So let's see what are the applications. By observing its properties, for which type of applications it is used. Here melting point is only 110 to 130 degrees centigrade. That's why it is not used in iron boxes, hot plates, like that type of applications as like Teflon, right? So what is the applications for this? Let's see. The applications are wires and cables, high frequency cables, TV and radio circuits, capacitors. These are the applications. And the next type of thermoplastic material is polyester. So what is this polyester? Already well known about this name polyester. We all are learned, already listened about the word polyester. So what is this polyester? Polyester is made from polyhydric compound and carbolic acids and is a thermosetting polymer. So it is a coming under the category of thermostatic plastic. So what are the properties for this polyester? And its operating temperature is up to 75 degrees centigrade only. This means it is very highly flammable. We have to take care while using this type of plastic, that is polyester materials. Some clothes are also polyester is there, no? Dielectric constant is 2.5 and resistivity is 10 to the power of 17 to 10 to the power of 19 ohm meter, and dielectric strength is 20 to 80 kV per mm, and it is hygroscopic. By observing these properties, what are the applications for this? It is used as capacitors. How it is used in capacitors? Capacitors contains one positive and negative plate. In between some dielectric medium we have to insert to store the energy. So this dielectric medium is here. This polyester is used. So in capacitor it is used as dielectric material, and this material is used in cables also. In cables it is used as wrapping material. Inside the layer of PVC, this wrapping is also there. If we insert the wrapping inside one layer of this cable, then only it is flexible to molding, flexible to handle it. After that it is used as electric brushings. electric bushings. These are the applications used in our electrical engineering. So polyester is used as dielectric material in capacitors and wrapping materials in cables, and somewhere it is used as bushings also. After that, PVC. This is important bit also. Mostly all the wires and cables are made with this PVC only. What is this PVC? PVC means polyvinyl chloride. Polymer of polyvinyl chloride polymerized in the presence of catalyst at 50 degrees centigrade. Vinyl chloride is obtained by the reaction of acetylene with hydrochloric acid. This is the chemical composition. Let's see what are the properties for this. The operating temperature is from 55 to 115 degrees centigrade. Dielectric constant is 5 to 6 and resistivity is 10 to the power of 12 to 13 ohm meter. And its dielectric strength is 30 kV per mm. And it is non-hygroscopic in nature. It is inflammable. It's not brittle in nature. Mechanically it is strength. So these are the positive features for this. Mechanically strong, inflammable, non-hygroscopic, dielectric strength, high resistivity, all the things is there. So what are the applications for this? Wires and cable films, tapes, dry batteries, conduits, like that. So this is a very important material rather than all the thermoplastic materials. This is a material widely used in our electrical engineering. So PVC means it is a synthetic compound. It is obtained by combination of this acetylene and hydrogen chloride in the presence of catalyst at a temperature of about 50 degrees centigrade. It can also be obtained by polymerization of ethylene dichloride and sodium hydroxide. In the presence of a catalyst. It does not react with oxygen, oils, alkalis and acids. Means it is chemically strong, chemical resistant. So what are the properties we are observed by studying this? It is rigid, hard and little flexible. We are also tell that it does not react with oxygen, right? By that what we are observed, it never gets corrosion. It is less weight and in cheap also, and it has high resistance to chemical action, and it is having resistivity of the insulation resistance is 10 to the power of 12 to 12 to the power of 13 ohm centimeters, and it can withstand very high temperatures above 80 degrees centigrade. It is normally transparent, brittle and hard. Its dielectric constant is 5 to 6. Its dielectric strength is 15 to 30 kV per mm. It is hard and rigid. It is obtained in different colors. It is slightly hygroscopic. It has good electrical and mechanical properties. So these are the properties we are observed in PVC. So due to these good electrical and mechanical properties, it has wide range of applications in insulation materials. It is used in insulation of wires and cables. It is used as insulation from dry batteries also. It is used as conduit pipes in electrical wiring system. And PVC insulated cables are commonly used for low and medium voltages, domestic and industrial light and power installations. It is used as insulation for wires in military, aircraft, communication, radio and television. So almost all the wires and cables are made by using the insulation material of PVC only, polyvinyl chloride. And at the same time it is used in dry batteries also. Overall in electrical wiring system it is used as conduit pipes. You observe that PVC pipes is there, joints, in your lab also we are used this PVC pipes. Inside that PVC pipes the electrical wiring is made. So in white and that ceiling roses, all the materials related to this wiring, electrical wiring is mostly PVC materials. The seal rose, this PVC pipes and the joints and four-way junction boxes, like that. So many small applications, different shapes and parts are used in the wiring. Almost all are these conduit pipes, all are made with PVC only. So PVC insulated cables are commonly used for what? Low and medium voltage, that is it is related to in all our domestic applications and light load applications, means industrial applications and power installation. Mostly up to medium level voltage the PVC only used. Beyond that the other insulating materials may be used, but up to this low to medium level voltages most of the insulating materials are PVC itself, and it is used as insulation for wires in military, aircraft, communication, radio and television, like that. So many applications. Sometimes it is used in tapes also. These are the wide ranges of applications of our PVC. So up to now we have studied about the solid insulating materials, impregnated paper, asbestos, mica and its products, ceramic materials, glass insulating materials. After that, then resins or plastics, and that natural plastic and synthetic plastic. This synthetic plastic also two types. One is thermosetting and is thermoplastic. After that, one more type of solid insulating material is there, that is rubber. So natural rubber is obtained from the milk sap of trees, but it finds very little applications in the field of engineering. So natural rubber is obtained from the milky sap, but it has not very much good properties like insulating material. That's why it has very limited applications in the field of engineering. The reasons are rubber is a stretchable material. Stretching means which is twice more than that its a original length without deformations. So what is this natural rubber? Natural rubber is extracted from the trees. This is a chemical composition. So what are the applications? It finds very limited use in covering wires, conductors, extra for low voltage operation also. Gloves, rubber shoes. For safety purpose, we are having some uniforms in our laboratories and in our substations like that. In that, we are used this type of gloves, rubber shoes like that. After that, hard rubber is there. Increased sulfur contents and extent vulcanization treatment gives rubber as rigid rubber properties. It has good electrical properties. Let's see what are the properties. First one is high tensile strength and maximum temperature permissible is 60 degrees centigrade. Operated continued exposure to sun is harmful. If it is continuously exposed to sun, then due to temperature it may be sag in nature. That's why these are the properties related to hard rubber. So after the applications, after observing these properties, which type of applications we are used means the construction of storage battery housings, panel boards, bushing of various types. Next is silicon rubbers. This is a silicon rubber chemical composition. Si means silicon, hydrogen and carbon, O is oxygen. This is a chemical structure for this. Let's see what are the properties for this. Silicon rubber possesses thermal conductivity twice than natural rubber. Their operating temperature range is very wide, stretching from 60 degrees centigrade to 150 degrees centigrade. And its tensile strength of this material is low, but stability at high temperatures is remarkable. They exhibit good flexibility at low temperature. Silicon rubbers are exceptionally Silicon rubbers are exceptionally good electrical properties. So by observing these properties, what we are identify here, the silicon rubber possesses thermal conductivity twice than that of natural rubber, and its operating temperature is very wide, stretching from 60 to 150 degrees centigrade. Here the tensile strength is low, but stability at high temperature is remarkable. At high temperatures also it is stable without stretching more, right? They exhibit good flexibility by observing this. This is an important point. Good flexibility at low temperature. So silicon rubber is used insulation for electric wires and cables, and in manufacture of molded parts. Electrical wiring, this is having more applications. Silicon rubbers, and cables also it is used. This rubber is stretchable material and it's very flexible in making different shapes, right? That's why it is used in molded parts of different shapes. At that time this is having the application. These are the insulating materials coming under solid type of insulating material family. After that, liquid insulating materials is also there, and gases insulating materials also there. The liquid insulating materials are mostly used as oils, that is mineral oil, kerosene oils, alcohols, just for lubricating oils, waxes, like that. And synthetic liquids also there. Vegetable oils. Vegetable oils are also used as insulating materials obtained from seed of cotton, sunflower, soybean, pulp, like that type of materials we are obtain these vegetable oils. And fluorinated liquids. Fluorinated liquid means it is similar to synthetic liquids but have very excellent cooling properties. Silicon fluids, Vaseline, varnish, like that. So what is the use of this liquid insulating materials? It is used as cooling oil or insulating oils like uh, in transformers. The mineral oil is used as insulating oil and it is used for the cooling process also, like that. In circuit breakers it is acts as medium, vacuum and other varnish. What is the use of this liquid insulating material varnish? This varnish is applied on the transformer windings to prevent from short circuit from one winding to another winding, like that. We need some coatings or varnishes for impregnation processes, like that. All those things, these liquid insulating materials are very much used. These are about the solid and liquid insulating material. Example for liquid insulating materials are what? Mineral oils. What are the example for this mineral oil? Kerosene, alcohols, lubricant, waxes, like that. Synthetic liquids, vegetable oils, fluorinated liquids, silicon fluids, Vaseline, varnishes, all are example for our liquid insulating materials. And the last one is, that is gases insulating material. So gases insulating material. What are the gases material, insulating type of material? The example for these gas insulating materials are air, nitrogen, hydrogen, inert gases like neon, argon, mercury vapor, sodium vapor. In lamps also we are used these inert gases, right? Sodium vapor lamp, mercury lamp, like that. Okay. Halogen gas, sulfur hexafluoride, carbon dioxide. Sulfur hexafluoride has its very good outstanding performance as insulating material. That's why a substation itself it is used as gaseous substation by using this sulfur hexafluoride SF6 only. Indoor substation, outdoor substation, like that, gaseous substation is also there. Due to this SF6, it give very insulating properties as well as cooling properties for this substation. All the equipment in substation, due to this insulation properties, it requires very less place for the complete substation. So sulfur hexafluoride is also very good application. After that, carbon dioxide. These are the different types of gaseous insulating materials. In detail, we study this gas insulating materials in our next class. Today, what is the outline for our video lesson? We had studied about the solid insulating materials like plastics, that is thermoplastics. After that, rubber. After that, liquid insulating materials. And its properties and applications of these insulating materials. And in the next class, we are going to study about the complete insulating materials related to gaseous and its properties and applications. Hope you understand this. Thank you for watching this.